Start again. So, hello everybody, this is the webinar number 39 about object-oriented programming. I keep doing these webinars every month, once a month, and this one will be about object relational mapping and how can we replace that in a practical project where we have the persistence layer like a database, relational database, and we need to have objects in our code. In today it's going to be Ruby, but you can apply that to any other language. So first of all, I'll give you a little bit of a background what ORM is, object relational mapping is, and why I think it's a bad idea. So on the persistence layer, there are a number of layers in any application. The persistence layer, they're so-called multi-layer applications. All of them are multi-layer. On some layer, on the lowest layer, we usually keep the data somewhere, and that data we keep in files or in the database in some storage. That's why it's called persistence layer. Then the next layer, sometimes called service layer, or sort of I don't know, service layer, probably the most common name, is where we store the code which manipulates with the persistence layer data and prepares that data for the processing or for presentation for the user. And then the next layer is some sort of application layer, or I don't know, presentation layer, more like presentation layer. So on the presentation layer we have objects or some scripts or something which gives that information, presents that data to the user. So we have persistence, we have service layer which serves or process everything, and then we have the presentation layer. So on the problem is, how do we get the data from the persistence layer and make it manageable or useful at the layer of at the service layer for the presentation layer. So the most common format how we keep the data in the, let me see whether you can see my code. Yeah, so the most common format is, let's say we have let's say we have a table which is like this, for example. So we have a relational table where we have columns, and then let me show you another example more like this. So let's say we have a letter. So that would be easier to demonstrate. So we have a letter. A letter is a record. A letter is the name of the table. And one record in the table is a letter, which has an ID, which has some foreign keys, which has some attributes, something inside. And then we need to have an ability to present that letter for the end user. So show it for the user. This is going to be the web app. So that's why the user is a web user with the browser, and the user wants to see the letter and wants to see all the attributes of the letter. So we have SQL database with a SQL table, and then we have an HTML page where everything from the table has to be rendered. So the most common approach, the most typical one, is to use so-called object relational mapping. There are two keywords, the object and relational. So in the relational database we have this piece, and then we need an object. We need something which will work like this: letter dot liquid, and then I can put it to the user, or I can say like this, maybe in the HTML. And since it's Ruby, then you most probably will do, I don't know what you're gonna do, but that's gonna be something in the HTML where you can actually get the value from an object and say, letter, give me the liquid, or maybe letter, present yourself in HTML, which would be better, of course. So we can say, show it to the user. I mean, print the letter HTML to some output, and then the user will be able to see that. So now we need somehow to connect that two elements. We need to connect the letter with this code. So here letter is an object. So first, before we can do that, we will say letter equals letter new and then something here, most likely. Or that would be, you know, perfect, but in most cases it doesn't work like that. In most cases it's some, I don't know, some engine, find letter by ID 1, 2, 3, and then we get the letter. It doesn't matter how we do that, but we want an object here. We don't want to deal with SQL. We don't want to, most of us programmers don't even want to know what that language is. Don't want to understand how SQL works. We want mapping. We want to map the relational language, the relational structures, which are tables, records, foreign keys, constraints, all that things, types. We want to map that stuff to the Ruby language or Java language or whatever, JavaScript language, and then deal with that stuff in our language locally. So let's say we find that letter somehow, then we say letter dot created. So created is the attribute, it's a column in the table, which is of type timestamp. I'm using Postgres, by the way. So this is the type timestamp. But here in, say, Ruby, I want to deal with that. I want to be able to say if letter created less than time minus now, then, I don't know, puts it is in the past. End. So I want to be able to do that. And I want, obviously, I want that thing returned by created to be of type time somehow, to be able to compare it with another type, with the type time. So I don't want to deal with this timestamp inside Ruby because nobody knows what timestamp is. Timestamp is something which comes from the relational database. So we need mapping. That's why the word mapping. We want to map two different worlds. We want to map the relational world to the object world somehow. And the way it's done usually, the way it's done in most situations is wrong. The way these ORM systems are doing that is wrong. I wrote an article about that like 3 years ago on my blog, and I said about that in my book, and I had a webinar about that about a year and a half ago about ORM. But I never demonstrated the real practical example of how it can be done otherwise, how we can do it not the way ORM systems are doing it. So how they are doing it. So let me show you how this find letter by ID may work in a more or less traditional ORM system. So how this method will be, implemented inside. It's going to be something like that. Plus or minus, take it, more or less like that. So we give the ID. So what it's going to do? It's going to most likely do something like that. Pool of connections, make the SQL request, select from letter where ID equals ID. Since it's Ruby, it's going to be, okay, 1, 2, 3. Doesn't matter. Well, it will take the parameter from here. I hope you follow. Let me save it so it's going to, give us the give us the highlight of the color. It will retrieve some collection of rows most probably, and then we take rows number 0, and that will be the row coming from the database. And then we will make something like that. Letter equals to letter new, and then letter ID equals row ID. Letter, that will be copy paste. Well, of course it's way more complicated there, but that will be something like that. Lane, active, liquid, and YAML, and created. That would be the code which of course the ORM framework is not going to do it like that, because the ORM framework will not know exactly what are the attributes, what are the attributes of an object are here, but it will try to do something like that. Ruby is, less strict language, and it's way easier to do that. Java is more strict, and in Java we will have to explicitly define setters and getters for these attributes, or make those things public. But anyway, and then we return it, and then it goes like that. So, and then here it will work. Of course, the created will be something like that, time parse. You see, so we will need to convert types. Here it's going to be text, active is Boolean, so we will say active equals to true, because active will be the string coming from Postgres. So it's not going to be Boolean, it's going to be, or maybe, no, it's T, yeah. So the T is the letter which will be coming from Postgres for the true, and F for the false. So we need to convert it to Boolean. Lane, it's going to be a foreign key, so it will be the ID, the number. So we cannot just say raw lane. We need to find that lane somewhere, so that later it will be possible to say letter.lane.id. So in order to make that possible, we will have to somehow create a lane here. So maybe we will do something, find lane by ID, and then raw, and then lane. I hope you follow, right? And then ID is an integer, but still, well, yeah, I think it's an integer. So that what a framework, an ORM framework would do inside. We don't want to implement that for every particular find operation. So the framework will give us the functionality, all the features, so that we will be able to say engine find letter by ID, or maybe it will even look like this: letter, meaning that the name of the table, and then I will do find by ID, and then it will work more or less like that. From framework to framework, it depends. There are many combinations, but the bottom line is that what we return back is as an object, sort of an object, which in reality is basically a storage of data. So you can see that the actual SQL request is done here. It goes to the database, then the data comes back, and then we create an object which is just a transfer object. It doesn't really know where the data came from. So the letter here, if, for example, in the letter I will say, let's say here in the letter I would be interested to say maybe reload from the database. It's not going to know how to reload. It's not going to know how to get the data again from the database. Or if I say, in most cases, if I say save, again, not in most frameworks, it's not going to be possible. We will have to do something like this: engine save letter. So we always have to talk to some framework, to some in some places it's called engine, in some frameworks it's called session. It could be also called in Hibernate. What's the name of that beast? If I remember correctly, let me open, because I don't use them. That's why I really don't remember what the names are. I'm opening my blog post. Yeah, it's called session factory, and then it's open a session. So I gave you the right name. So we have a session in Hibernate. It could be a session, could be an engine, could be something like that. But still, we have three participants in this conversation. We have me, this script, which needs to do something. I'm sitting here at the presentation layer, as you can imagine. So I'm the presenter. I want to, to do something with that objects coming from somewhere. Then I have the engine, which knows how to deal with the persistence layer, which knows how to deal with Postgres. And then I have my objects, my transfer objects, my the storages of data which I pass around, which are coming from the engine, and they come to me and I deal with them, and I have to always talk to two parts. I take them from the engine, I deal with them, and I return them back to the engine. It's not really object oriented for many reasons. You can read my blog post and you will see why this is wrong. What I propose, and I'm getting to the point, what I propose is to let the object itself know how to take the data back. So let's say that's how I would do it instead. Created. And then I call letter created. When I do that, I jump into the method created, and then the method created inside the object letter knows how to get to the database, how to retrieve the data, and how to show that data on the surface, how to return it to the surface. So there are no two parts anymore. It's not one engine and one object which I have to deal with I have to dispatch between. I don't need to take the object from one place and then take the data from that object to another place. I just deal with the letter. I say letter equals to letter new, and then I say letter created. That's it. I don't take it from anywhere. I don't, I have a pretty solid object which knows everything about SQL, about the database inside. Again, read the articles about that, about the philosophy of that. I'll show you now the practical examples. I'm deleting that file. Let's forget that. And let's go into real class letter, which is coming from a real project. This project I explained on my blog about 3 weeks ago. It's called Mail Lanes. It's a email. It's a newsletter management system where we have letters, we have lists of users, recipients, deliveries. So basically it's a system which sends emails, and I'm using it for delivering emails for my blog subscribers, for our promotion campaigns, for the subscription to our Xerocracy websites, everywhere. So the system works, and it works pretty fast. It's a real system. You can try it yourself. It works fine. So look at the class letter, how it works. As I promised to you, we have the method created. Well, I don't have the created because nobody needs that information anywhere, but we have the method liquid, for example, this one, which does this code, select liquid from the letter where ID equals to ID. It does everything which I just promised you. And let's see, because there's some code around it which I want to explain to show you how I deal with the performance issue, because you can imagine there will be performance. But first of all, let's look at the constructor, the most important element. So the letter encapsulates a number of things. First of all is the ID. So every time I create a letter, let's take a look at the unit test so you will see how it really works. Do I have that thing here where I just create a letter? Yeah, we don't have for one letter. So I can't really demonstrate you from a unit test, but let's look at the code. So the first parameter is ID. It's the number in that table. This is the ID here, because we need to know which letter we are working with. The second parameter is called PGSQL. That's interesting, and this is the default value. You see, it has the default value, but in the real code, it's not the default one. We inject. Let's look at that class. Here it is, PGSQL, which has just one public method. Well, this one is also public, but I think it's a mistake. So it has just one public method, which is called exec, which means execute the SQL query and the query and return everything which you manage to take back from manage to retrieve from the database. So we inject basically the database connector into the letter. So every single letter we take from the database, every single object coming from, well, we create, which knows about a letter in the database, knows how to find that information in the database. So that letter is so-called SQL speaking object, which is the name I suggested in the blog post 3 years ago. So the letter speaks SQL with the database through this adapter, and the adapter is encapsulated. So it's not possible to create a letter without injecting and encapsulating the connector to the database, because the letter wants to know how to find all the necessary elements for it to survive. And the last one, interesting element, it's called hash. I'll explain you in a few seconds. But let's first look at the very simple case, which is the retrieval of, for example, the field, the column, which is called liquid. So what do? We take that connector, we call exec, which is the method to execute SQL, and then we inject select liquid from letter where ID equals to $1. $1 is the substitute, substitutor for the value, and then we provide a collection of substitutors. This is the array, and the array is the ID, which is the ID of the letter. So obviously this request will return a collection of, well, actually going to return just one row or nothing. Thanks to, it's going to be one row or nothing. And then we take the row number 0, which is the first one, and then from that row we take the column liquid. You may obviously ask me what's going to happen if there will be no row, if there is no letter in the database. It's not bulletproof, because the Ruby will return nil here, null pointer, and the null pointer will obviously be null pointer exception here. So the code is not perfect, because the perfect one would be to check for the null pointer, check that code for the null pointer. If there's a null pointer, we need to raise an exception and say there is no letter in the database. I think I'm doing it somewhere. I had that in the code somewhere. But anyway, if I want to make it better, I would do it like this. Rows. Let's do it this way. So I take the 0, 1, and this, and I say if raise, there is no letter in the database with the ID, like this, if row nil. That's perfect. That would be the perfect code. Well, more descriptive. The exception would be more descriptive. There would be exception anyway, but that would be null pointer exception, which nobody will understand what the cause is. This one is way better. It explains what the problem is. And then we're getting to the hash parameters. So let's see how we create. Now we're getting to the performance problem, which I think most of you want to ask me about, because if every time we do that combination of requests, because this is actually a full round trip to the database. So we go to the database, we take one particular column, and then we return it back to the user. What if the user wants to get this column, and then that column, and then that column? So there's going to be a number of them, like place, YAML, liquid. They're all different, and they all have similar code here. Look, for the YAML thing, we have exactly the same code. See? Boom. Like this. For the place, we have exactly the same code. Like this. Boom. So we keep doing the same stuff again and again. And if the user will want to call 1, 2, and 3 methods just to collect some attributes, some values from the raw, then it will be 3 round trips to the database. And that's true. In order to optimize that in this real application, what I did is that I know that most of the letters are coming from the letters class. The letters is just a collection of all letters. So you look at the letters which belong to a certain group of letters, and then you take from there. You take letters one by one from there in order to show them in the list or somehow. And then when you do that, you do it like this. Letters dot, first of all, you initialize letters. You also provide the connector into the constructor. And then when you want to see all letters, you call the connector. Then you call select me star, which means everything, from letter, where lane equals order by created, blah, blah, blah. It doesn't matter. What matters is that it returns a collection of letters from the database, a collection of rows, which every row will include everything which a letter may contain. And then we want to make and then we call map, which is, mapping a list to a list, array to array. And then for each row, we turn each row into an instance of class letter. We create a new class for each row we manage to find in a database. And then we provide the ID, which is the ID from the row. This one, we convert it to the integer. And then we give the connector again, which is encapsulated in the class. So in each letter we find, we inject the connector again and again. And then we give the hash. And the hash here, is the row we managed to find from the database. So it's sort of a pre-cached, it's sort of a pre-calculated cache, which we managed to fill, which we managed to retrieve from the database. And then we just inject it into the letter, all the data we have, and we give it here. So we give it as a parameter to the constructor. So we're like saying, look, you're the letter, I know what's the ID of you, this is the connector for you to the database. So if you want some data, if you want to do something with the data, you go talk to the database, and you know how. But I'm giving you the hash map of attributes, of column values, which you may use if you don't want to go to the database. You may use that values because they are more or less accurate. Of course, there's no guarantee that because they stay in memory. So maybe between the moment I gave you that hash values and the moment when somebody will actually come to you and say, hey, give me the value of the liquid column, nothing is changed in the database. So maybe the database will be updated. But that's fine. It's more or less okay for my application. And that's why I give you the hash. And here, when I take the raw liquid, I'm saying, look, if you have it in the hash, then return it. If you don't have it, or return what's coming from the database. But look, this code will, it's not, so I made a mistake by refactoring all that, because here we actually don't save, we don't actually resolve the performance problems, because it's gonna go to the database anyway. But we don't want that. We want actually, we want to get it back to how it was before. And that's how it was before. So it looks at the hash and says, hey, do you have liquid? If you have it there, just return it. Otherwise, go to the database, return it from there, take the raw number 0, and then take the liquid from there. That's how it works, and it's pretty fast. You can look at the application, you will see that sometimes when you just want one letter, in that case, you will initialize it with the empty hash. And then, multiple connections here will actually, there's going to be multiple requests here, here, and there. But in most cases, the letters are coming from somewhere. They're coming from a collection of letters. They're coming from somewhere where it is found, and it's all the values are injected there. And now the next question, yeah, and let me show you how it talks to the SQL database in other places. For example, look, I wanna know in which campaigns. It's the method campaigns. So I want to know return the list of campaigns of where this letter participated, and where this letter participates returns, this method returns the list of campaigns where this letter participates. So I talk to the letter and I say, hey, give me the list of campaigns. It builds it builds the SQL query. So it does understand the language. It does understand the SQL language. It's not a dumb data object anymore. It's not a dumb, it's a primitive data transfer object. Not at all. It does speak the language of the persistence layer. It knows how to build the SQL, to build a SQL request. It says select star from campaign, join letter on something, where letter is something. So it's not complex, but still it's a query. It talks to the Postgres and knows what to do with the return. So what's coming back? Again, we're using the same connector. We're saying execute the query, and then we map the return, all the rows we map to campaigns. We say, look, for each record we managed to find in a database, create the campaign object and put the ID here, give it the connector again, and give it the hash. So later it will be easier, it will be faster to deal with those campaign objects because they already will contain pre-calculated cache. It's quite convenient. Another example, do something with save me something. Okay, save liquid. So we know how to get the liquid out of there. And I'm saying, okay, can you please save something to the database? Again, no problem. We have the connector. We execute the request. We say update letter, set liquid, where ID, and then we provide some parameters here. And what we do afterwards, we clean up the hash. That's important. So if I don't do that, you understand that that object will still contain the data inside that attribute, which is not going to be the same as what we just updated to the database. So I won't be able to get the liquid, save the liquid, and then I will say, get it back to me again, and I will get the previous value. So for that not to happen, we can say hash equals to that, or maybe that would be even better. Hash liquid equals to liquid instead of this. So instead of cleaning up everything, I can just, replace the liquid element in the cache. But I'm doing this everywhere. Again, maybe it's not optimal, but I just feel that it's safer because when you do update, if I would go with this code, then I will have to know that these two lines are connected. So if tomorrow I can get back to this line and say update letter, blah, 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 do something else with something else, change something else in the database, I don't know how exactly, I may change that request, then that line may no longer be valid because there will be not enough to clean up, to expire our cache. That's why I'm doing the save operation, just saying forget about everything which was pre-cached and just move on. And remember that these objects, this letter, campaign, all of them, lane, they all pretty short living entities. So they are created, the connector is injected there, they live for a few milliseconds while the web request is coming, and then they just get thrown away. So that's why we don't really care that much about cleaning up that hash, because we don't really want that letter to stay alive for a long time. It just gets created when the HTTP request is coming. We create the letter object, and then it lives for a few milliseconds. Then we just throw it away. So that's why it's perfectly fine to deal with it like that. What else I wanted you to show in that aspect. Insert. So sometimes I want to attach a file to the letter. You know, when I want to send somebody a letter, then there may be a file. So in that case, I say I do insert here as well. So again, the connector, again, I call exec, and I say insert into blah, 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 some other table here. So that's interesting, that's important. So the letter object not only deals with the letter table in the database, not at all. So there's no one-on-one mapping like in ORM. So we don't map the letter to the letter database, to the letter table. There's no mapping anymore. We just know how to deal with the entire database while working with the letter. So here I'm saying attach a file to the letter. So what's going on? I'm saying insert into attachment. I'm not even touching the table letter. I'm doing something else with another table. But it's still in the scope of the letter class. So this is not how ORM works. In those object relational mapping systems, they are, usually one-on-one. So there's exactly one class in Ruby or in Java or whatever, and then exactly one table in the database, which is silly in my case, in my understanding, because relational world is relational world, object world is object world. There should be no one-on-one mapping, because the structure and the logic and the design of objects, it's a different story from it's a different world, it's different there are different principles there involved. Like here, look, I want to be able to say, and it's pretty logical to me, letter attach file, right? And then I want to say letter detach file. I know, file. Attach, detach, it's pretty logical. But in order to do that, I need to deal with another table. I need to deal with a table called attachment. Look, detach is delete from attachment, insert into attachment. But on the surface, for the user, it's a collection of operations, of methods of the class letter. Make sense? And then I have another method, and I say deliver. So then I will be able to make a letter. I want to say letter new, ID 123, and then I will do letter deliver, which means I will actually send it over the network, and I will go by email to the recipient. So this deliver code, it's pretty complex code which actually does the actual work. It's not about only storage. So the letter is not just an abstract around the persistence layer and just a gate to the database. Not at all. It does deliver the letter to the end user over SMTP, over email protocol, which is not how data transfer objects work. But this is how object world has to work, because on the surface, again, I want to say save liquid. Let's see the unit test. You will see what I mean. Here's the unit test, and for example, attach and detach. I'm saying letters, create me a collection of letters. Then I say letter equals letters.add. So add me a new letter. This is the new letter. And then I have the name of the file, and I have a body of the file. And I say letter attach. Attach me a new attachment. And then I say equal, I do the assert that letter.attachment.count equals to 1. I just attached, I expect 1. And then I say letter.attachments, the first element of the array, the name of that attachment is name, because I just attached it. And then I say letter download the name, download the attachment into the file. And then I compare what's there, and then I say letter detached, remove the attachment, and okay, letter attachments empty. This is the language I speak with my objects. Here, I don't know what kind of database they're working with. As you can see, I have no idea. Find by ID, not find, save object, not save, update, insert. This is completely, this logic is completely hidden from me here. Here I deal just with an object. Letter, attach, detach, download, remove. I'm speaking the language, I'm speaking the object-oriented language. And this is how it should be. If I would be using ORM, I would be speaking the language of relational database. I would still remember what are the tables. Here at that level, I don't know what the tables are. Do you? Do we need to know that? No. Do I know that there are attachments table, there are table letter, table attachment, maybe there are some other tables? I don't care about that. But if that would be ORM, I would need to know that because the relational world would be mapped to my object world. And then my entire thinking, design, mindset will be completely twisted in order to remember and to stay in the world of tables and columns and foreign keys and what have you, and triggers. But this should not happen. We need to speak two different languages. And that's why we need objects which are so-called SQL speaking objects. So they know how to deliver, they know how to, I wanted to show you how to deliver. So yeah, okay, look, test sends via SMTP. So what I'm doing here, I am creating again the letter. Doesn't matter, it's a preparation code. So I make a letter, then I create a random port. So I acquire a random TCP port, I create a temporary directory, and then I start an SMTP daemon, which is a fake daemon. This is not my library, I got it somewhere. And then I say letter dot save YAML. So I save the configuration of what to send to. So I'm telling my letter that this is going to be your configuration from now on, and you will be delivering emails by SMTP to this target endpoint. And then I create some codec, to encrypt some data there. And then I say, okay, start me the daemon, start listening for the incoming emails. And then I say letter, deliver, recipient with this codec. So the letter is not a database structure, it's not a database record anymore for me. It's a properly designed letter which can be delivered, can deliver itself to the recipient. And then I say, okay, no matter what happens, stop the daemon, and then I start to assert that actually something was delivered. So I'm checking, I'm reading everything. I'm reading all the files which were delivered, and then I'm checking: did you have that header? Did you put that header? Did you? If everything was fine, then I just finished the unit test. So that unit test demonstrates, and I actually wrote that like 2 months ago. So that code I never touched since probably July or maybe August this year. So it was 2 months ago, and I just opened it right now for you. And I easily can read it and easily can remember what it's doing, because at this level, there's no database language anymore, as you can see. Do you see anything about Postgres, about fetching some data, about finding something in the database? Not at all. It's just a proper object-oriented, dialect. This is, I think, what I wanted to demonstrate to you. And I will try to look at your questions. Yeah, you have some. So let me go through the questions and I'll try to answer some of them. Yeah, the first question was, I think I answered it already. So I have 5 fields in the database. There will be five separate SQL queries to get the fields. It's not efficient comparing to getting it all together. Like I showed you, I know it's not efficient. That's why I have this hashing hash attribute in all my objects. Another one, there's why ORM-free better than ORM using when implementing SQL speaking objects? Actually, I'm not sure I understand the question correctly, but this is something which I didn't mention as of yet. So here we have a very plain primitive way of talking to the database. As you can see, there is a lot of code duplication here. If you look at the code, you see in many places almost the same SQL statements. So when I retrieve yeah, here's the, let's get back to the original. So if I retrieve, so look at this code. Look at this line and look at this line. They are almost identical. So would be potentially, but I didn't do that because I didn't know exactly how to do it right, but that would be potentially good to create some other class or maybe a collection of classes where I would be able to do something like that. Maybe select, new, maybe I'm just fantasizing here. I'm just trying to. So maybe I would say this, and then I would say this, and then I would say arguments this, and then I would say hash this, and then I would say column liquid. And then, for example, fetch. Maybe that would be a solution if we can make such a, yeah, that would be probably, yeah, in that case the query we don't need. We will say like table letter, I don't know, and remove that. Maybe something like that. I'm not sure, but it doesn't look to me like shorter than that line, to be honest. So it's one line. Here it's going to be, well, we can put it in one line, but I feel, that's my personal, feeling that actually removing the language, which I like the SQL language. It's quite, nice and it's good to know it. It's good to know exactly what's happening. Exactly when I'm saying deliveries count, then I want to know how exactly it counts in a database. I want to know that it count ID or count star. Maybe it's a different thing. Then I want to know it's how it counts. Maybe there is some I don't know, sort by or something like that. So I want to touch the SQL query every time. I don't want to deal with that stuff because here it's something which I don't see. It's something that happens somewhere in some unified way. You may say that in a unified way you can do it, with a more predictable way. You will not make mistakes. You can get rid of the duplicate code. Maybe. I'm not against that. I just don't know how to do it right. So if you can invent some good solution for doing it better, that would be awesome. But I'm still doing that. I'm still duplicating the code. Look, this line, it's quite similar to that line, and I say whatever, it doesn't matter, because when I look at this particular method, I just look at the method and I deal with one particular query. But I'm not insisting here. Another question, maybe the hash lesser should be another class. Maybe, I just don't know what is hash lesser, but maybe. Another one, this is another comment. This is active record, but without base class. Yeah, it's active record without base class. Yeah, that's right. It's like somebody's keep telling me that our, the Zold cryptocurrency is blockchain without blocks and without chains. Yes, the same here. It is active record, but without the base class. Is it really active record without base class? I don't think it's any more an active record. Another comment is you should write a lot of SQL code instead of one select star. You also have separate queries for each field. Yes, you have to write a lot of SQL code. If you look at my classes, look, this is ladder, this is lane. Look, there's select. If you look, there's a list. Again, select, update, select. The big queries, look, they're quite large, some of them. They're even like really, big. And I write a lot. Look at this. This is SQL query right inside the class. And I keep look at this one. And I keep writing them because I do know the language. I find it interesting to write. I like to write SQL queries, and it's obvious, and it's obvious for me what it does, and it is how it should be, I think. So when the object says do something with the list, then I know what exactly will be done here, and I can test it. I can understand it. So I think that's what SQL speaking objects are. Look, some of the queries are quite large. These ones are most, I think, the largest ones I have. Another question. Hash is a bad name for hash map. That's right. When do you actually need to detach file? Well, sometimes you attach a file to the email and then you want to detach it because you don't need that file anymore. So you detach it from the user interface. If you log into maillanes.com, here's the name of the project. It's called maillanes.com. So if you log into that system, you will see that you can create a letter and then you can attach the file and detach. So it's possible to execute stored procedures by some triggers from objects. Yeah, absolutely. You can run stored procedures. You can work with triggers. You can do whatever. You can create new tables. You can do whatever you want from inside your objects. So your objects become quite powerful structures. They know how to deal with data, and they work with the entire database. The entire collection of all tables, not just one-on-one, not just I am the letter, so I work with the letter table. Not at all. I work with the entire database. Don't we need a separate class for attachment? That's a good question. So like I showed you, the ladder is managing attachments, and attachments come and go, but we have another table called attachment, and we don't have a class attachment. Right now we don't have that because it will be enough for me just to have three methods: attach, detach, and download. But if it starts growing, I can move those stuff from another class, and that class will work with another set of tables. But that decision is dictated by my object-oriented requirements, by my object design, not by the design of the database. Next one. Can we still hide all the SQL procedures in a separate file? Yes, we can if you want to. If you want to move some SQL code to some separate files, just do that. For me, it looks more convenient to stay together. Another question, I found it complicated to use some SQL transactions with multiple SQL speaking objects. How do you handle transaction management with SQL speaking objects? Transaction management, I'll show you one piece for the transaction. Let me find it. For example, this is transaction. So I have the campaign. I have an object campaign, and I want to merge that campaign into another campaign. And here I want to do that. And in order to do that merge, I need to run three queries. I need to update something, then I need to update something else, and then I have to delete something from something. So in order to do that, I don't use .exec anymore, like here. I don't execute anything right there. Instead, I say, okay, open the connection for me, and then I deal with the Postgres code directly, because this .transaction, it's something coming from the original library for Postgres. And then I say .transaction start, meaning that .transaction starts the transaction, and then the connection comes in, and then I say execute with the parameters, execute with the parameters, execute with the parameters. So I basically, run the transaction like you would do in any other language. How to deal with other objects? But look, target is another campaign. So here I'm just taking the ID from the target because I need it. If I would need something else, I would take something else. I think I have the transaction in another place. I think I remember that. Oh yeah, that's transaction. That's the code I showed you before. So that's pretty large. So look, I start the connection, then I start the transaction, and then I do one, boom, another one, boom, another one, boom. So I do 3 large queries. Delete, update, delete in one large transaction. And it all goes together in that operation. That's how I deal with transactions. Yeah, the question is, what about transactions? For example, you want to create a letter and an attachment and one transaction. Like just I showed you, just transactions are transactions. I just use them, and that's it. So another question. So in case with SQL speaking objects, we can execute some query that can trigger stored procedure. Yeah, absolutely, we can. Why do you mix declarative and imperative? Well, that's a pretty abstract question. I do mix. I cannot write entirely declarative. That would be quite difficult because all the code around me, all the libraries, all the products which are coming from different authors, they are mostly procedural and they don't have objects, some of them, or they have objects with just a huge collection of methods. So I can't really write entirely entirely declarative code. Another question, the last one, I think. We're running out of time. How did you come up with the idea? It seems dirty and against the rules, but looks much more convenient and human, if I may say. Well, I just didn't like the rules. I didn't like how people, I didn't like my code, which I was working a lot with Hibernate. It's in Java, and I was using Doctrine in PHP. That's my experience with ORMs. I never used anything in Ruby, and I also used something in Python. I was trying to, in Python it was, I don't even remember the name, and I remember like 4 years ago I was trying to create the Python application, and there was some ORM. So I just didn't like it. I didn't like the code which was created. I always felt that I was just copying the relational structures to my code, and then I move. The relational language, the SQL language, is perfectly designed for maintaining data, for managing data, where you have relations, you have, you can select from that relations, you can update those relations, you can do many things in that language. But it's not but it's just silly to move that logic and that structures and those structures to object-oriented code. But with the ORM, I had to do that, and I didn't like that. That's why I started to think, how about do this a little bit different, in order to give me the ability to live with to manipulate the SQL language, which I love, and still stay with the Ruby code or Java code, which I also love. So that's it. I think I gave you everything I had, and check the code if you want. It's mail lanes. The application is open source. You can check it out yourself, read the blog, and see you next month. I'm trying to make those webinars every first Wednesday of the month, 11 a.m. Pacific time. Thanks for watching, and bye-bye.